So section 3.9 is called linear functions. Basically, we're talking lines here. And so most of the stuff I'm going to talk to you about today, you probably already know. The only thing that might be new or different for you would be special notation. Other than that, if you know how to come up with the equation of a line, it's going to be pretty easy. All right, so first of all, we've already talked about the formula for the slope of the line. It's m equals what? Y. Oh, that's the equation y equals mx plus b. You're thinking something else. To get the slope of a line, you take 2 points.
Y2 minus y1 over x2 minus x1.
Yes, y2 minus y1 over x2 minus x1. You might also see this referred to as rate of change. Okay, so if they say, what is the rate of change? It's basically asking you for the slope. When you get to a class called calculus, you're going to see, bless you, you're going to see a triangle y over a triangle triangle x. This is a Greek letter, I think it's delta. It just means the change in y over the change in x, which is what you're doing with that slope formula. The difference in the y's over the difference in the x is just how much are you going up or down, how much are you going right or left, okay? Next thing on the list is slope-intercept form, which we've already talked about in here. Now you can tell me, Grace. Perfect. Y equals mx plus b. Super easy. All you do is plug in the slope for m. You plug in the y-intercept for b. And the only thing that's going to be different about example number 1 is we're going to do something called function notation. All right, so for example number 1, I'm going to give you a graph. We're going to write the equation. So for the graph, we're going to sketch our x and y axis, our coordinate plane. I'm going to put a point at 2, 0 right here and a point at 0, 3. 1, 2, 3. That's going to be the line right there. We're going to first put it into y equals mx plus b form, using the information from the graph. So we need 2 things. We need the slope and we need the y-intercept. So for slope, if you're given a graph, you can just count it. So start at one intersection point and go to the other intersection point. This one's going down, so it's obviously going to be negative, right? And then it's going down 1, 2, 3. So 3 is in the numerator. It's going over 1, 2. 2 is in the denominator, okay? Then we need our intersection of our y-axis. So we count up 1, 2, 3. It's at positive 3. So when we plug those 2 numbers into our slope-intercept form, we get y equals negative 3 halves x plus 3. Up until this point, you've seen this all before, right? This is nothing new, okay? So now all we're going to do is we're going to write this in something called function notation. You're going to take this y equals part, and you're going to change it to f of x, and then the rest of it stays the same. Negative 3 halves x plus 3. And you're going to write your final answer like that. Any questions so far? Super easy, right? Okay. So what if you're not given a graph? Instead, you're given 2 points. So this is example number 2. So I'm going to give you the 2 points in function notation. And then we're going to write the equation. So we're going to end in the same spot. You're just given something different. Okay, so function notation looks like this. The function of 4 equals 1, and the function of 8 equals 7. Okay? So when you're given your points in function notation, the first thing you want to do is just write them as points. This means the number that you plug in for x. Whatever number's in there is your x. Whoops. And whatever number spits out is your y. So your point is 4, 1. Same thing with this one. This is the number you put in for x. The number that spits out is your y. Okay? So you can think of it as input, output, xy, xy, x1, y1, x2, y2. All those apply. Okay, so we're going to take these 4 numbers and we're going to plug them into our slope formula, right? Technically, you could graph them, count the slope like we did in example number 1, but we know the slope formula too, so let's do that. So we're going to do y2 minus y1, 7 minus 1, over x2 minus x1, so 8 minus 4, and then just simplify. 7 minus 1 is 6, 8 minus 4 is 4. What does that reduce to? 3 halves. So that's our m. Are either of these 2 points our y-intercept? They would be if it was 0 some number, but it's not. So we need to pick one of these points and figure out what is the new b. Okay? So which point do we want to pick? Let's pick the first one. Okay, so we're going to say y equals m, which is 3 halves x plus b. Okay, so we're going to take this 4 and plug it in for x, take this 1 and plug it in for y. So we're going to have 1 equals 3 halves times 4 plus b. Notice I've plugged in everything into the equation except for the b. That's going to get us a new b. Okay? If it helps, change this 4 to a fraction. But you basically just want to multiply the 3 times 4 and divide by 2. I get 6 plus b equals 1. So when we subtract 6, I got b equals negative 5. So down here we have a b of negative 5. Up here we got an m of 3 halves. So we're going to put that into slope-intercept form, which is y equals 3 halves x minus 5. And then we just want that fancy notation. So we change it from y equals to f of x equals 3 halves x minus 5. Okay.